So before you even start thinking about CI/CD, I would very much like you to do everything manually, because I often hear people, they're saying like, well, CI/CD is really important to us and it will solve all of the issues. But my experience is that if you do not master this process manually, you are doomed to fail while doing it automatically. So in particular, what I noticed is that most of the companies out there that are struggling with CI/CD or that perhaps are having a bad experience is maybe because they don't have a proper testing strategy. Maybe they don't have enough liveliness probes into their containers in order to make sure that, well, the deployment is stopping its rollout and things like that. So my suggestion is start first doing everything manually, and then and then at the point where you're confident that, well, the manual process is working correctly and is kind of getting, boring and, just useless waste of time, it's at that moment where you should really think about CI/CD integration. And that's also why
first understand and understand the whole process and manual and then automate it.
Exactly. If I were to give a comparison, you never learn how to fly with an autopilot when you're in your first day of flight school, right? You would first go to the basic principle of how do I control this machine to begin with. And then when you finally master this, then you would know how to also use the autopilot. Similarly, also with the car, you will never learn how to drive by cruise control or by speed limiter on your first day. It's the fact that you have a machine between you and the actual system that you want to control, so be it the cruise control or CI/CD pipeline, actually makes things more complicated for you in the beginning, because you now need to understand not only the system, the final system that you want to control, but also the integration between you and that system. So make sure that you understand each piece separately before you put them together. And I just wanted to highlight that our documentation very much reflects also this mindset. So CI/CD is rather late in the user guide, exactly to send out this message that you need to master a lot of things. For example, setting up proper alerts in case something goes wrong with your application or the rollout doesn't work properly, before you can think about CI/CD integration. Now, when it comes to CI/CD integration, Compliant Kubernetes does not come up with its own solution. It does not impose anything like that. It's battery not included when it comes to CI/CD pipelines. However, it can be integrated with pretty much any CI/CD solution out there that you want to use. Basically, the most important thing that you need to think about when integrated with CI/CD solution is access control, because doing this wrong can pretty much invalidate all of the hard work that we have been putting into making Kubernetes comply with various data protection regulation. And in this demo, I will show you how to make sure that, well, you don't compromise access control when setting up CI/CD integration. Before actually starting to show my terminal around, let's briefly discuss about two styles of CI/CD pipelines. So I hear very many people that they think CI/CD is one thing, or they think that it's another thing. They're actually talking about, let's say, two completely different styles of CI/CD. So let's clarify this from the very beginning. So you have certain styles in which basically you have a CI/CD worker. My favorite system is GitLab CI or GitHub Actions that listens to changes in your Git repository, and then upon these changes is running a script or is running a workflow or an action, whatever. The terminology differs slightly from CI/CD pipeline to another, but the principles are the same. And these will then push changes into the Kubernetes cluster. And when you're doing this kind of thing, it slightly simplifies triggering actions as a result of changing the Git repository, right? Normally, we have very tight integration between these two systems, both in GitHub and in GitLab. So the second you push something to Git, GitLab and GitHub will immediately react to that and will make the necessary changes. So that integration is a bit easier. On the other hand, you need to be a lot more mindful about how exactly are you going to give GitHub Actions or GitLab CI access to your Kubernetes cluster. And besides, I'm going to demonstrate in this particular, today I'm going to demonstrate how you set up the right credentials in the CI/CD pipeline, but you should also probably think about IP whitelisting, for example, or sorry, IP allow listing. Do I run a GitHub runner locally, in which case I avoid some of the discussion about IP allow listing, or do I actually use Microsoft's hosted GitHub? And in that case, I need to have a process for making sure that the IPs of GitHub Actions is also somehow allow listed in the Kubernetes cluster. Now, the second style is what I would call the pull style, in which case you have a component running inside the Kubernetes cluster, usually Argo CD, but there are other great solutions such as Flux CD also, that are integrated with a Git repository and then listen for changes. So when I say listening to changes, this can happen in two ways, either via polling. So every 5 minutes, Argo CD would check with the Git repository, hey, do you have any new changes or not? Or sometimes it's possible to do a bit more reactive integration by setting up something like webhooks. And at the end of the day, Argo CD then takes those changes and so pulls those changes and then again connects to the Kubernetes API to enforce those changes. And in case you're looking for the second style of CI/CD pipelines, in that case, you need to worry a lot more about how are you going to give the Kubernetes cluster or the component inside the Kubernetes cluster access to the Git repository. Will you create like a separate Git user? If your Git repository, for example, is internal and is isolated from the production environment, which I have seen happening in some environments, how exactly will you make sure that the Kubernetes cluster has access to it, and so on. And right now, I feel that there is no better or worse style. It's just trade-offs, and make sure that you're choosing the solution that is the right one for you and for your organization. Today, I will demo the push style CI/CD. So I will show specifically how to use GitHub Actions in order to push changes that I make in a Git repository into the Kubernetes cluster. However, be mindful about the fact that this works for any kind of push style CI/CD. So it works both for GitLab CI, for GitHub Actions, for Azure DevOps. If you're still using Jenkins, it works also for that, and so on. So please focus on the principles that I'm about to highlight and not on the exact technical solution. Okay, so I said that one of the biggest concerns when you're doing push style CI/CD is how are you going to give access to your CI/CD environment, to your production Kubernetes cluster. And you want to be sure that you're giving the minimum access that is required for CI/CD pipeline, otherwise you risk violating your access control policy. And to this end, we have here a process that I'm going to demonstrate right now. So the first thing that you should do is always check if you're on the correct cluster. So here I see that I'm on my demo environment, seems to be the right cluster, that's good. Let me check if I'm also in the correct namespace. So I'm running in the namespace demo1, that's great. And now let me check what exactly my user can do. Knowing that Kubernetes has so-called privilege escalation prevention, so I cannot create a role which has more permissions than my own user. So then I will type this command, kubectl auth can I, and then ---- list. Let me maximize this to make this a bit clearer. And here, for example, I would see that, well, when it comes to config maps, I can create, delete, patch, update, pretty much do everything with them. I can do the same with pods, with services, and so on. However, I am, for example, not able to say, say for the nodes, yes, I'm only able to get, watch, and list nodes, and I'm only able to get, watch, and list namespaces. And this is already where you need to think a little bit about what exactly you want your CI/CD pipeline to do. Do you want it to create namespaces? I would personally recommend against it, but it's your choice. Does it need to, for example, create secrets, or do you rather want to manage secrets outside your CI/CD pipeline and then just give access, just configure the deployments to allow access to from your application to those secrets, and so on. And like I said, this is a very good moment to think about, okay, which exact permissions do I need the CI/CD pipeline to have in order for it to successfully complete its task? So in my case, I am going to use our user demo application, which is available in our public documentation. and I already know it by heart, so I can tell you with great reassurance that it pretty much creates some services. It needs to create a deployment, and it needs to create an ingress object. And so these are then the permissions that I need to make sure that my CI/CD pipeline receives for that purpose. So then the first step would be that I need to create a role for my CI/CD pipeline. And fortunately, we already provide an example for that. And let me show you how that works. So I will go here in Compliant Kubernetes user demo, and then I will look in deploy CI/CD role. And as you can see, I have created a role for the CI/CD pipeline. It's allowed to fully manipulate config maps, pods, secrets, and services. Same with deployments. It needs replica set in case you want to use Helm upgrade -- wait, which makes a lot of sense in certain cases. It's allowed to create horizontal pod autoscalers. That's also something that is very commonly used in applications. Ingresses, which you need in order to give access from outside the cluster into your application. And then Prometheus rules and service monitors are in order to export metrics and to set alerts for application-specific metrics. And network policies are, like we discussed at length in previous sessions, are pretty much the equivalent of firewalls in the Kubernetes world. So this feels reasonable, right? I did not give my CI/CD pipeline too many permissions. It really makes me feel confident that, yeah, these are truly resources that need access to, that it needs to create, destroy, and so on.
And what's the main reason you don't want to give the CI/CD pipeline, say, all the permissions in the cluster?
That's actually a very good question, Simon. Unfortunately, they're having quite a lot of attacks that have not targeted production infrastructure directly. Rather, they have targeted the CI/CD pipeline. And this is often, let's call it a more neglected attack vector. The CI/CD pipelines are usually very powerful. They're often allowed to create and destroy infrastructure. They're often running backup jobs. They're often used to enforce various workloads. So if your CI/CD pipeline is under attack and somebody managed to get more permission than necessary there, then they are in a very good position to then infiltrate into your production environment and potentially do damage to customer data. So by reducing the amount of permissions that your CI/CD pipeline has towards the production environment, you are further reducing risk and are minimizing the damage that can happen in case an attack is happening.
Thank you. That's a good answer.
Alrighty, so now that I reviewed the CI/CD pipeline, I am going to create a role. And the role in Kubernetes terms is pretty much just a collection of permissions, right? So as you have seen, what objects can be manipulated and with what verbs can be created, updated, deleted, and so on. But now I need to also give this role to something. And as we have previously discussed, Kubernetes usually prefers you to make a strong separation between user accounts that identify humans and that are taken from your identity provider, and service accounts that are associated to other systems, such as systems within Kubernetes, such as the various Kubernetes controllers, or your CI/CD pipeline. So to this end, I'm going to create a service account for the CI/CD pipeline. And I forgot to mention something that maybe is interesting at this point. So if at some point I try to give the CI/CD pipeline, I try to create a CI/CD role that is more powerful than myself, this operation here would fail and it would give me a big warning. I can even demonstrate later in case you're interested about it, but otherwise our documentation also highlights this error and tells you how to recover from it. Okay, now that I created a set of permissions, a role, and that I created a service account, it's time to actually bind the two together and pretty much say like, well, this service account will have access to, will be bound to that particular role. Okay. And just to show what I've done so far, So kube control get roles. I have a role called CI/CD in the demo1 namespace. Kube control get service account. I have a service account called CI/CD in the demo1 namespace, and then role bindings. And then I have a role that binds the two together so as to make it clear that that particular service account is bound to that role. With that being said, now I have a service account. What do I do next? I somehow need to take this service account and to configure it in my CI/CD pipeline. And in order to achieve that, I'm going to extract a kubeconfig from the service account. So maybe I can also demonstrate this a little bit. If I do, each service account is associated to a token, which contains pretty much the same information as a kubeconfig would for a regular user. And is this token that I want to extract, and then I want to take and configure in my CI/CD pipeline. Now, for some reason, the format, the shape of this token is a little bit tricky. But if you just want to get the job done, so to speak, simply copy these commands here, paste them in your terminal, and voila, at the end of the day, you will just get a magic kubeconfig, which is suitable to be used in your CI/CD pipeline. Handle it with care, because anybody who can disclose this, who can see this, is going to pretty much be able to do whatever your CI/CD pipeline can do against your Kubernetes cluster. I'm going to type it out here just so that everybody can appreciate its shape. Be mindful about the fact that I have already, by the time you see this particular video, I have already erased this service account and these roles, so don't even try to hack me. Yeah, and as you can see, it pretty much looks like any kind of kubeconfig out there with the certificate authority of the cluster, and then it's a token-based authentication. For people who are fluent in reading base 64, you might even recognize the beginning that is specific for JWT tokens. And this is what will identify towards the Kubernetes API that, well, you're trying to connect to Kubernetes with this particular service account. Okay, now that we actually created a kubeconfig that has everything that is needed, let me now show you how to actually use it. And this part is very specific to GitHub Actions, but like I said, it doesn't need to be. The principles are pretty much the same for GitLab CI or for Jenkins or for Azure DevOps. So I have already created a small fork of the official Compliant Kubernetes documentation. The reason why I created a fork is because I didn't want to add a GitHub action for this particular demo in the public documentation, so I just do it in my private repo. And here I have created a file called app deploy, which contains the workflow that is specific for app deployment. And for those of you who have already used GitHub Actions before, this must feel really familiar. So I'm basically just reacting on pushes on the main branch. I set here some environment variables, which are pretty much taken from the documentation. Let me actually show you side by side how to manually configure the application and then what the CI/CD pipeline is doing. And you tell me if there is a huge difference or not. But as you can see, if you want to manually deploy your application, we recommend to configure a few environment variables, and that's what the CI/CD pipeline is also doing. And afterwards, you essentially need to run Helm upgrade. And that is exactly, I just copy-pasted this command. I didn't really think it through or process it or anything like that. I just copy-pasted it in the CI/CD workflow. The only thing that is, let's say, a little bit trickier is the fact that, well, I need to somehow inject a kubeconfig into this particular environment, and that's where I'm going to focus most of my attention to now. So in this particular case, I basically chose to send the kubeconfig as its content, base 64 encoded, as a secret to the CI/CD pipeline. which then needs to be deserialized and pretty much put into a kubeconfig. And then in order to make kubecontrol happy, I'm also setting some permissions to make sure that the kubeconfig is not world readable, which Kubernetes kubecontrol doesn't really like to see. Okay, and at least in GitHub Actions, there are two ways of setting this particular secret. Either you make it a repository secret, in which case that secret is available to all of your workflows, or you can make it an environment secret, in which case you have to specify for which environment, which environment secrets do you need in this particular action, and then you have a little bit of a better separation, right? You might have one action that only runs for staging, or one action that only runs for production, and you can do a little bit of a cleaner separations of kubeconfigs. So that is the approach that I have done here. I have pretty much configured a environment called staging. And so now all that is left to do is for me to configure an environment secret. So I'll say here, new environment, staging. And then I add here a secret. This one is, in my particular action, this is called kubeconfig content base 64. And then let me take this kubeconfig base 64 encoded. And then copy paste it in GitHub. Okay, the secret is configured correctly. And just as a precaution, I would very much recommend you to immediately erase the kubeconfig from your laptop, just to make sure that this particular kubeconfig doesn't sprawl and you don't get, that you really know for sure that, okay, you transfer this particular service account to the CI/CD environment, and that's the only place where it's configured. Okay, so what do you think, Simon? Shall we actually check whether this is working?
That sounds very good. And we're actually having an alarm here in the building. There's no danger or anything. I think it's just a door, but I don't know if you guys can hear the loud beeps.
We can hear beeps, but not loud ones.
Okay, good. I'll try to mute myself when I'm not talking. But yeah, let's go ahead and see if this is actually working.
Okay, so let me run kubecontrol get pods -- watch. So this is not something that you do on a daily basis, but I just do it for demonstration purposes. And then let me here do some kind of dummy commit. Allow empty, and then I will say force CI/CD execution. Okay, and then git push. Right, I forgot to put my YubiKey in, which is required in order for me to have access to GitHub. Any minute now. Okay. So I can show you also what's happening in GitHub while we're at it. So GitHub will have detected that the Git repository has changed, and it will immediately run the pipeline. This particular pipeline is, well, organized in the steps that you have just seen. Pretty much there is a setup kubeconfig step, and then there is the deploy step, which, yeah, this particular step is just creating the kubeconfig, and then this particular step is just running Helm upgrade as you have seen also when I did this particular step manually. And then these messages should also be familiar. It's pretty much what you would have seen in your own terminal had you run these commands manually from your laptop. And then at the end of the day, the application is being deployed and it works. And I can actually also show that, well, I had the terminal in the background which did kube control get pods -- watch, and it's pretty much what you would expect. So the containers are being created, they are being set to running, and everything works as expected. And I can also show maybe a change. So this is the first time that I'm deploying things. Let me also demonstrate a change that I could do. Not claiming this is the best way for you to change things. I just want to demonstrate that the CI/CD pipeline actually works. So let's say that I want to add a, I want to decrease the replica count. We determined that this application doesn't really need that much replication, so there's no point in setting replica count to 2. So I can either set replica count to from here, or I could change the GitHub action. Let me do it from here. And then if I now say git commit, I actually like to git add first to make sure that I only commit the changes that I want to, okay? Then I commit. And now if I'm pushing, then I should, of course, this machinery will be a bit slow, right? Because GitHub actions will first need to detect that I made a change in Git, then it will need to actually queue my job for execution. There is a bit of a setup time, right, until my particular job is being loaded and things like that. But eventually, it killed one of the two. Eventually it created a new deployment, and then the deployment controller killed one of the 2 pods because I only asked for a replica equal 1. And I can show this also without watch, just to make sure that, well, I can demonstrate that indeed right now there is only 1 pod of my application run. Yeah, so that concludes my demo. I would also like to add the fact that I pretty much demonstrated here only continuous delivery. If you also want continuous integration, then as I have demonstrated previously, you can use Harbor robot accounts, and then you'd use those as a secret in your CI/CD pipeline. And then it's pretty much the same principle. You just Docker build, Docker login, Docker build, Docker push, done. And then afterwards, you would need to seriously think about, do you want to do CI first? So pretty much just create container images based on source code, and then do CI separately, maybe in a different process or by a different team than CI? Or do you just want to build the image and immediately deploy it in production, which is also something that has its advantages and you might want to consider doing?
There's a lot of different options to consider for sure.
Exactly. So and I wouldn't say that there's a better or worse option. I think that you simply need to take a decision on that, document why you made that particular decision. It could be that this decision also needs to change. So maybe while you're a fast-moving company with few users, you might just want to fuse CI/CD together just to get code shipped as quickly as possible. But then later, as your product matures and your user base increases, you might want to be a bit more careful, and then you might want to detach CI from CD. So you might want to, for example, only build the container images in phase 1. Then you might want to have a CD pipeline that pushes all of those changes to staging, to maybe a user acceptance environment. And then only when you convince yourself that everything is fine, push those changes into production. And then you can have simpler or more complicated rollout plans. Again, depends on where you are with your user base, basically, and the maturity of your product. And what are you more worried about? Are you more worried about downtime, or are you more worried about your product not seeing sufficient uptake? Whatever your choice, Kubernetes has a solution for all of them.